All right, we're looking at 6.4, where we're dealing with similar triangles. The new thing you should probably write down on your postulate and theorem page is angle-angle similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles must be similar. Okay? So we're going to look at example 1. We're going to look at example 1. We're going to list all the pairs of congruent angles and write the statement of proportionality.
Who is that?
Your mom.
My mom's dead.
First of all.
What if my mom is dead?
So,
What if my mom is dead?
ladies and gentlemen, all right, so we've got angle-angle similarity. So we know that angle A is congruent to angle P, and angle B is congruent to angle N, therefore they must be proportional to each other. So we're going to list all pairs of congruent angles. Angle A is congruent to angle P. Angle B is congruent to angle N.
Wouldn't it be,
Therefore,
wouldn't it be angle C is congruent to angle 1, 2?
angle C is congruent to angle N. And then if we want to write the statement of proportionality, we know AB is over PN. We know CB is over MN. And we know CA is over NP. I'm not going to do the others. They're all the same.
Yes.
If you know two of the angles are congruent to each other. Let's look at C real quick. I'm not going to do the whole thing, but I'm going to ask you how you know. We know angle M and angle K are congruent. What other angle do we know is congruent?
J and J.
Angle KJL
Yes.
is congruent to angle MLJ, and we know that because these two are parallel, and those are alternate interior angles. Okay, let's move on to example 2 then. Okay, we're going to find the value of x. We know these two triangles are similar, and we know which angles are congruent to each other. So angle C and angle M must be the same.
Yeah.
So that must be x. So we know x plus 3x plus 80 equals what? Oops, what did I wrote this wrong. X plus 3x plus 80 equals
180.
180. I accidentally wrote that on the board. So we have 4x equals 100. So x equals 25. So we know C and M are both 25. What is A and P? What's 3 times 25?
75.
75. They're both 75. Does that make sense? Okay, we want to find x for here. We know y and z are congruent. We know x and x are congruent. They're overlapping triangles. So we can set up proportionalities. I'm going to take the little one, ty, and I'm going to put it over wz. So then I'm going to take the little distance here, which would be 17 minus x over 17. And I got 17 minus x because I know that little part is x.
Wait, when
And I know this is not 17. That's 17 minus the little x.
wouldn't you have to reduce 15 over time?
You don't have to, but you could. It would make it easier to do the problem. Okay, you could make it easier to do the problem and get 3/5 fourths. You don't have to, but it would just make your multiplication better. And then you go 3 times 17, which is 21. 3 times 1 is 3, 4. 42 equals 4 times 7. 7 times 4 is 28. 4, 5, 6 minus 4x. Subtract 68 from both sides. This is 6. 6 minus 4 is 2. Divide both sides by a negative 4. And you get 4 goes into 26. 6 times with 2 4s left over. Yes. What? Yes.
How did you get this?
You need to write this down faster than what
No, I've already done it. No, just green.
Okay. Should I do the third one, or you guys feel pretty comfortable with these two?
I'm
Do the
completely
third one.
Want me to do the third one?
Yes.
And yes, you would plug. You don't need to plug anything back in because it just asks for what x is. Okay, so we're looking at this. We have x, 11.4, and 8.2. Okay, so we've got two triangles. They both share the same side, 11.4 over 11.4, and then it would be x over 8.2. So what do you think x is going to be? What is 11.4 over 11.4 reduced to?
1.
1. So what do you think x is going to be?
8.2.
8.2. Because it would also have to reduce to 1. They're just, there's as if they're two triangles, right? We know that's 11.4, so this is 11.4 and this is 11.4. This is x and this is 8.2.
Do one more.
So they have to be the same. That is the last one for that side, so there's no more. Okay, let's look at example 3. Determine whether the triangles can be proven similar. If they are similar, explain why and write a similarity statement. Are these two triangles, could they be similar? No. Not similar. Angle C does not equal angle A, and it would have to. What about this one? This is B. Are they similar? So we've got two parallel lines cut by a transversal, which means the alternate interior angles are congruent. So we've got angle-angle similarity.
Yeah.
Right? So these are similar. So ABD is similar to ABD is similar to ECB. Okay, what about C? They've got angle Y and angle W. What other angle do they have in common?
Z, Y, T, Y, T, Z.
No.
X and
They don't have
X
any.
and X.
Oh,
Two overlapping triangles, right on top of each other.
I knew that. So that's a yes.
So they are similar. So yes, triangle XYT is similar to triangle XWZ. Okay, let's look at example 4, which I believe is on next.
We got part B.
Alright, and then we got for B. Example 4. Using similar triangles in the coordinate plane. Okay, we've got zeros. O is 0, 0, so this is at point 0, 0. B is at 0, 4. D is at 0, 7. And C is at 3, 0. And it asks you, find the coordinates of E. What is the distance between 0 and C? It's 3, right?
Yes.
Okay, which is, okay, so that's corresponding to C to E, which is we don't know.
B0,
Okay, and then we have B to 0 to O to B, which is 4, over 7. So we cross multiply. 3 times 7 is 21, which equals 4x. Did I set that right up?
It's like
Yep. So we divide both sides by 4, and we get x would be 5.25. So E would be at 5.250.
yeah, how do you set it up?
Yeah. So the distance between 0 to C is 3. The distance between 0 to E, we don't know. The distance between 0 to B is 4. The distance between 0 to D is 7. So, because it's at 0, 4. I mean, it's a triangle, right? The corresponding sides.
I see.
So the vertical ones and then
I see.
the other ones.
Gotcha.
Okay, let's look at B.
If you did it 7 over 4, you still got the same answer?
Then you would have had to do x over 3. Because it has to be the little one over the big one or the big one over the little one for both of them.
You still got the same answer?
Okay, the triangles are shown. Find the value of the variables. So we know that they're similar. So we're going to move them around so that they have, so we say 7 over 3.5 or 3.5 over 7, doesn't matter, equals, let's find x. X over 10. Cross multiply, we get 35 equals 7x.
5.
Both sides, x equals 5. So here's the hard part. How are we going to find y?
Oh, right here, right here.
Yes.
Because 10 is, okay, so.
How are we going to find y? What kind of triangle is it?
Equal angular?
A
Scalene.
right triangle. And if we have two sides of a right triangle, we can always find the third by doing what?
Pythagorean theorem.
Yes. 5 squared plus 3.5 squared equals y squared. 5 squared is 25. Who's got a calculator? What's 3.5 squared?
3 times 2. 9, 25.
12.25. Can you add those two together, please?
27.25.
25 plus 12.25 is?
Yeah, 37.
37.25. And then find the square root of that.
Yeah, I don't know.
6.1. All right, this triangle, right? These two sets of triangles right here. How do we know that they're similar? We see parallel lines, so I know the alternate interior angles are congruent. What else do I know is congruent?
Two sides.
These two are congruent because they are
Vertical.
vertical angles. Remember, we're looking for angle-angle similarity for these. Okay, so I've got to kind of move it around so I know x over 3 is the same as 2 over 5. So 5x equals 6, so x equals, we'll just leave it at 6/5. Okay, and then I've got 2 over 5 equals y over 7. So 14 equals 5y, so y equals 5/14. Okay. And I'm not going to do the proofs, but I am going to give you extra credit if you do them. So you can earn extra credit by doing the proofs. They have to be correct, of course, to earn extra credit.
So there's not. Hold on. So there's no proofs on the test.
Right.
Oh, okay. So these are just extra.